Hello friends, welcome to my class. My name is Kamal Sarma. I am a structural engineer for many years. I am a structural design engineer in the United States for last 20 years. I am designing bridges and other retaining wall or some other kinds of structures for all these years. Before that, I was a faculty in Assam Engineering College for 13 years teaching structural engineering subjects. I did my Ph.D. from Ohio State University in structural engineering. I did my master's in structural engineering from IIT Roorkee, and I did my bachelor degree from Jorhat Engineering College in Assam, India. I have seen that many people struggle with this subject structure, and I feel that I would like to make it easier for you to get good grades in a class as well as become a very good structural engineer. First of all, we should know what structure is. Structure is something constructed for taking loads for some useful purpose, Useful purpose may be your staying inside the structure, that is called building, or crossing a river, like bridge, or passing through the mountain tunnel, or water retaining structures. All these are structures. Structures are designed to make sure that it doesn't collapse under the load. Okay, the loads are coming from three different ways. One is self-weight, or the part integral to the structure itself. The other is coming from its use. We call it is live load. Use means suppose you are staying in a building and your own human loads, your furnitures, etc. will be the live load. Or you are constructing a bridge, the vehicle moving over it is a live load. The third load is coming from the nature. You see, nature has a lot of forces coming from nature, something like the earthquake, wind, snow, water pressure, and also the earth pressure. All those things are natural loads. So under all these loads, the structure should be able to withstand all these loads and transfer the load to the ground. You see, most all loads are transferred to the ground. So we need to have a good foundation, and soil conditions should be good to take the load from the superstructure, which is called the top of the structure, to the ground. That is very important. Okay, so now the structure actually evolved with human civilization. Probably the cavemen, they learned how to build their house with trees and leaves, etc. They from that use timber. Eventually they learn how to make structures with clay and bricks or stones. Then gradually they know how to use steel and develop concrete, reinforced concrete, pre-stressed concrete, like that. So the structure is evolving with the human civilization. Right now, currently, we use concrete, or reinforced concrete and pre-stressed concrete. And I will explain all this later. Then steel. These are the two most commonly used, concrete and steel, commonly used material in structures. Besides that, you can see structures with timbers, aluminum, and masonry with bricks and stones. Okay? So, I would like to explain the structure. I told you the structure is something which is stable under the load. So you might be considering what do you mean by stable, or what it is not collapsing. What is that meaning? Suppose I will explain in the help of a table. Okay, this is a table, just ordinary table. Okay, this table is not a structure. It can take load from the top, but if you push it from side, it will move. Okay? So this one, I already drawn this picture of a table there on the board. Okay? So, but I want to make this table like a structure. What I should do, see, if you put a load from top, it will take the load directly to the ground. Say it is ground. But if you have a load from this side, lateral load, it will move. Okay? To make it stable, what you should do, what I am doing, I am having some holes on the ground. Okay? And I fill it with concrete. When the concrete settles down, it will look like a structure. That means it can take the load. Only problem is that this joint here and there. Okay? To strengthen the joint, because what will happen when if I take this frame, this one, as if you take it separately, suppose this is your this frame, this particular part. This is something like this, right? When I put a pressure force there, P is the force, then it will try to sway like this. Okay? So that means these are not very strong enough to take this load, this sway. To strengthen it, what I will do, I will connect this one with this place, connect this and that with some members. This member is called, I call it bracing. So what the bracing does, it doesn't let it go like sway like this, going move like that. What it will do, it will be like this. If you draw it properly, so it will be like this. The force is there. Part of the force will go here. Part of the force will go there. You see, I am drawing these arrows opposite to this force. Okay, see, watch it. This is a force. If it is like this way, it will opposing to this side. This will be something different. This one is something different. I draw it. I'll explain what it is. What happens? This P, part of the P will go here. So you can say R1, and part will go R2. So R1 plus, if it is, this is angle is theta, cosine of R2 cosine of theta equal to your P. That means that P is resisted by these two members. These are the reactions coming on the member, that is the member forces. Okay? So how I know this? Because you see what happens when you have some member, if it is the arrows are like that, we consider that member is in compression. This is in compression. And if it is away from the joint, it is tension. Now here, what happens? This is compression, this is in tension. How I know it? Take this case. When there is no member like that, it will move like that, right? this is going like this. Sway some amount at this point. So when I connect it like this, what happens? This is the distance between this and that is shortens. When I add this member, it tries to push this member because it tries to make it short. So this member also push it back. So that means when the member is under compression or pushing inside, there's compression, so I know this is in compression. But the other side, it is lengthened. Distance from here to here is increasing. When I put the member like that to like that, what will happen? This member, this will try to elongate. This try to elongate by this action. So it is under tension. It's pulling. So this is something like that. So that is by looking at the behavior of the structure, we know what is the characteristics of a particular member under the load. I will explain about this. This is a truss section. This type of member, when I add this frame, this is a truss section. Truss section is something like that. When the force is transferred through the axis of the member, suppose this is something like that. If this is a member, this is a structural member, when the force is along the axis, this is called axial force. When the force is along the axis, doesn't matter if it is tension or compression. It may be compression or it may be tension. Okay? So if it is like that, so this axis, this is in the case of truss structure, in the case of truss, all the forces are axial, either compression or tension. This is the characteristic of truss. We have got truss and frame that I am going to explain now. What is frame? This is a truss. This side with the bracing, we make it a truss. But you can, if you consider this is a building, the whole thing is a building, not your table. Okay? Just table demonstration, I am showing it because to explain it. No one will have a table as a structure, believe me. Because people have structures for some purpose. This table, the small table, if you make it, fix it like that, it has got no use. Nobody is going to have something like that. So what you do, consider this whole thing is a building. Okay? And in a building, what we have? We have got a foundation. That foundation will make it wider a little bit. Because the loads coming from a building is very high. We make it like this. So that it distributes to a wider area, so that the reactions from soil can easily take the load. There should not be punching. Punching means if it's going through the soil, something like that. It is not allowed. So we make it distributed to a wider range. So whatever, this is the foundation. Similarly, this is called foundation. Okay? So we make it wider. Okay? But one thing, in a building, you need to have doors and windows. You need to have doors and windows, right? If you have a bracing like that, there's a conflict. There is a conflict. You can have the doors and windows. So what we should do, then we have a special arrangement. We make this joint should be strong enough without having abrasion. Okay, we cannot allow to have abrasion in that case, in a building. So what we will do, we do not have a bracing. So what happens? This type of structure without bracing, this is called frame. Understand? The frame is something like that. This is moment resisting joint. There's a joint there from this and that. So what is the characteristics of joint? When you apply some force, the angle between this member and this vertical member is 90 degree. This is also 90 degree. Right? So what happens when it under the load, it will sway. It will sway like this. But the angle between this remains 90 degree in frame. So it will be deflecting like this. It will be deflecting like this. This angle remains 90 degree. That is the characteristics. So when you do not allow the rotation, that means there is no difference in that the rotation between one member rotate against the other, then there is a moment developed. Resisting moments. Okay, I will come to that later. But this is the difference between frame and a truss. The frame, this is fixed. In most cases, sometimes they hinge also in special cases, but mostly fixed. But in a truss, you see that truss, when I do it, this is not moment resisting. We consider they are hinge. They can rotate. Okay, the angle, the relative angle between the members may not remain same. So that is the difference. Now, as I told you, suppose this is the building, right? So in the building, as I told you, this is foundation. We call it foundation. That means it takes the load transferred to the ground. What is the name of this? This is column. These are members. The column may be circular. If you have the cutted section there, it may be rectangular, okay, or it may have a shape like this if it is steel. There is the major axis, minor axis, all those things I will discuss later. Okay, so this is a beam. If it is concrete, usually concrete we have rectangular shape. This is deep, this is depth, and this is breadth. Usually, the depth is more than width or breadth. Then we may have, this is also this one. This beam may be of this. If it is steel, it may be mostly a section like this. Okay. We'll discuss that. This is your beam. And the top part, which covers the whole thing, whole building, is called slab. Now, what happened? This is mostly in slab. It is made of concrete in most cases. Okay, in bridges also you will find the concrete. The slab is always concrete. But the beam may be of steel or concrete. And the columns also, as I told you, it may be steel or concrete. And foundation is mostly concrete. Okay? There are different types of foundation. Okay? This foundation I am showing you is called shallow foundation. It's shallow. But we may have the deep foundation also. We have got piles underneath. If the soil condition is very bad, we use piles, or it's called deep foundation, or we can have the caisson or drill shaft. We may have drill shaft. This is circular in shape. In bridges you will find mostly the shaft, drill shaft, or the piles. This is a drill shaft. Or caisson, and in piles. This is also called caisson. But piles are also used in bridges, and they're also in certainly the soil is good. We go for in bridges. We go for shallow foundation also. This is all about structures. So what happens? You see an interesting point. This slab, you see this is a slab, right? The top part is a slab. I am drawing the slab. This shape is like that, slab. What happens? This slab load goes to the beam. How it goes? If you divide this angle, 90 degree, 45 degree, 45 degree, if you divide it in 45 degree, these two will meet here, these two will meet there. Okay? So if you join them, so this part will go to this beam there, this part will go to the beam here, and this part will go to the beam here, and this part will go to the beam there. This is tributary area. Okay? So what happens? The load comes from slab to the beam, this beam and that beam. That beam eventually transfer the load to the column, and the column eventually to the ground. So the way the load is passed through the top to the bottom, the path it follows is your load path. Load path is the load that comes from top all the way to the ground, where it follows. So here from the slab, it goes to the beam transfer to the load to the column goes to the foundation. Why it is important? It is simple here. In some cases, there are primary member and secondary member. Primary member. So suppose if in case of bridge, actually, take the case in case of bridge, there are two big girders looking from top. So there are some cross floor beams also. Then there are some stringers like that. Smaller beam. Stringers means smaller beam. This is bigger beam. And these are floor beams. So top, this slab, this load from the top goes to these beams called stringers. The stringers pass the load to the floor beams. The floor beam transfer the load to the girder. So this is the load path. From top, the slab pass the load to the stringers. Stringer pass the load to the floor beams. Floor beam eventually pass the load to the girder. So this load path is important. So you know, once you know how the load is transferred, it is easier to understand, easier to analyze the structure. You know which was the primary. This is your primary member. These are secondary members. Okay? So we should be careful. So all the load will be carried by this one. We should be careful about the primary member. If the primary member fails, everything goes down. Okay? So that is very important. So this is all about load path. Now, what happens is, this is all about the structure, but why structural analysis is important? Why structural theory of structure is important? Okay, and you know the structure. I explained the structure. So theory of structure. What is theory of structure? That is important. Okay. So suppose you have a construction. You want to construct a structure. This is the construction part. Construction. You want to construct something, some structure. So what you need for construction? What you need? You need something like, what you need? You need for the construction, you need some drawings. You need some drawings. What is these drawings? These drawings are something like this. This is the drawings we in our company we made it with the help of technician, draftsman. So these drawings we need for the construction. Otherwise, how these people who is constructing, how they will know how to construct, what is the size of the members, what are the dimensions of the members. They always follow the drawings. Okay? So when they follow the drawings, what they will do? How the drawings are aligned? How can you make the drawings? Drawings are drawn by some engineers, right? And a consultant. I'm a consulting engineer, I'm a design engineer. So in the consulting engineers or designers, what they do, they have the dimensions of the structure. Length, breadth, width, height, whatever it is, in a breeze case, the span, all these. What they will do, they will have a computer model. They put in the computer. There are all different kinds of software. They put in the computer, and the software will model it with assuming some member size. And they analyze it. It's called analysis. So at this stage, your first view assumption or the sizes, then analysis, then when the analysis they find the sum of the members assumed are not sufficient. They increase the size, again analyzing. So this is analysis. If you say analysis, and design. What is design? Design is finding out the member. finding out the member size, the rebar, or whatever is needed there, that is called design. So this goes back and forth. They analyze it, then after they design it, again it is not safe, it goes to the analysis, then again come back to design. This process goes on for a while. Eventually they arrive at the safe structure. That means all members are safe. They will not collapse. And deflection are also reasonable. Deflection. Two important points you should remember in structural analysis. Stress. I will explain what stress is and what is deflection. These are the two important things. Okay? The stress is, you see, when you apply some force on a member, on a structure, suppose this is your structure, you apply some force. I told you earlier that there is a force here, there is a force there, right? So what happens? This force, I told you it is R1, this is R2, okay? So R1, if you divide by the area of the cross section, area, that is your stress. The stress is actually force stress is actually force is actually force per unit area. This is the definition of stress. And deflection is, you know, deflection is anything, if you have something like this, some beam, it goes down, right? When I bend it, the part here is the maximum going down. That is the deflection. How much it deflects. So that is deflection. This deflection and stress are both important in always in structural analysis. Now, structural analysis, for structural analysis to finding out the force and stresses, stress and deflection. Another is deflection, right? You need to know about the structure. You need to know the behavior of the structure under all these loads. And this, where you find it, that you will find, that is the structure, that subject is called theory of structures. What is theory of structures? It gives you all the theories that helps you find knowing about the structure as well as analyze the structure, finding out the stresses, finding out the deflections. These are very important for structural analysis. These are very important for designing a structure. So what is there? This is the construction, this is drawing, this is your design stage. And this design says we use both design and analysis of the structure go hand in hand. After that, we prepare, when we are satisfied with the design, we prepare the sets like this. Okay? We have to have drawing like this. This is called plan. We call it plan. We call it plan. These are untitled construction plans. There are many. Here probably about 56 pages. You see, after designing, the engineer has to sign. Here it will be my signature, which may say the professional engineer. And here the roadway engineer has to sign. This is the bridge. It's a bridge of 75 feet span, single span bridge. From here to here, it is 75 feet. Understand? So we need to come up with a plan like this so that the construction people can easily construct it. How can you do it? Ordinary person cannot do it. We should know about the structure. We should know what are the stresses and deflections, because the structure cannot exceed the stress, the allowable stress. That's important. Otherwise it will collapse. I will discuss in later class what is allowable stress, how far we can go, what is the different kinds of design, all this. Then the deflection. In bridges, we cannot allow the deflection to go L over 800. This is the empirical formula. So probably in India or other countries where the matrix system is used, they might have a different equation. L is the span in feet and 800 is a number they found out. And this is the deflection. This is the deflection due to live load. There is a way to neutralize the dead load deflection. I will explain that later when I take the bridge class or during this session. Okay? But this is important. If we cannot use this, cannot exceed this value, L over 800. What happens if you exceed that value? What is it is found? The driver feel insecure. That means when he go over it, he feel like he's sinking. Okay? So he doesn't feel comfortable. So he will not go use the bridge again. Okay? So that is important. We cannot exceed certain limit. There's a called serviceability. So that is the criteria. Deflection is the criteria for serviceability, and the stress is for strength. You see, in design we have got two criteria we have to meet: strength and serviceability. So deflection goes to the serviceability conditions, where even in some structures it may satisfy the strength condition. That means it will not fail. Okay? But this criteria governs. That is, there is excessive deflection. When I discuss all this, I will talk about that. So today I want to conclude at this stage. Next time I will take it from where I left. So I hope you enjoyed the class. I hope I cleared some of your doubts. If you have any question, you can write it in comments. I'll be glad to answer those or explain in the class. Okay? And if you have any special question, you can ask me in the comments. I'll be glad to reply or explain in the class. And this is it. I hope you enjoyed the class. I hope you success in your career. I want you to see as an excellent structural engineer. And your success is my pleasure. Thank you very much. And see you next time. Bye.